Hi, just me again, still not knowing how to zoom in on this. I just do this. Maybe, I don't know. We'll see. Anyway, this is a really long lesson, so feel free to pause a lot and talk things through and then listen to my explanation. So on 87, or basically what we're doing today is we are learning how to rearrange equations and solve them for the variable that, like solve it for a different variable. And so on 87, we're talking about going back to the big race. And if there was an equation of y equals 3x plus 4, how much of a head start would that person get? And we knew it was 4 seconds because they began. I said 4 seconds. I meant 4 meters. Sorry about that. So they began 4 meters ahead of 0. So please make sure you write 4 meters. I apologize for that. And then what was their rate of speed? Well, rate of change, the speed is going to be the slope. And so you know that they would go 3 meters per second. So then looking at 88, it says you could find the slope and starting value of y equals 3x plus 4 because the equation is in y equals mx plus b. But what happens if it's in a different form? So if I gave you negative 6x plus 2y equals 10, this is considered written in standard form because it has the x and the y on the same side. So we've done everything in slope-intercept form so far. So can you easily tell what the slope and the y-intercept are? Looking at this. So play with that, see if you can come up with some predictions. I didn't predict because that's weird for me to do that. I want you guys to predict. But I want you to notice is that it is not as easy as finding M and B. So then moving on to this one, I am going to I'm going to do this as a separate video, I believe. No, I should just pull it up now, shouldn't I? So I'm going to pull this up. You pause while I am pulling this up, and you try to do this problem. Okay, so we are here. We have go to background. You want the equation mat 2, and so then now we can pull them in. So we need 2 y's here. Since they were negative 6y to start with, we are going to put them down here in the minus side. And then up here, we have 10 ones. So 1, 2, 3, 4, 5. Okay, so once you get them all, remember the first thing I like to do is to get rid of this subtraction side. But in order to flip it up here, you have to change the sign. So all of these will then become negative when you flip them up here. And then what the problem asks for us to do is to get y by itself on the left side. And so right here we've got 2 y's. So if we want to get y by itself, we need to move all of these x's over here. So if we're going to move them to the side, remember we're going to you can do it 2 different ways. You can add 6 more x's to the side to see that they cancel, or you can flip them to the side and change the sign when you flip them. Now you will have 2y plus all of this mess here. So then what I like to do is flip them to the side here, and then we are going to divide these 2 things. So if there's 10 little ones, that means that for each one, there would be 5. Then we would have 5 of them down here in this group. And then with our x's, put 1 at top, 1 down here, 1 at top, 1 down here, 1 at top, 1 down here. And you're going to see that each y equals 3x plus 5. So now that you know that each y equals 3x plus 5, C on there says what would be your slope and your y-intercept. So remember, your slope is how many x's there are. That's how much it's changing each time. So your slope will be 3. Your beginning point, your y-intercept, would be 5. Okay, so now that we have that, maybe I should keep that up there for a little bit longer. Pause if you need to catch up, or maybe pause to talk about what I just did there. And then when you're ready to move on, so am I. So now what we're going to do, so we're down here, and it says many times in the real world situations, a formula with more than one variable may not be in the form you need. The previous problem showed the standard form of linear equations do not show the slope and y-intercept until they're solved for y. That is, until y is isolated on one side of the equation. The formula and the problem are used in many different jobs. Sometimes you need to solve for a different variable in the order of the formula, or in order for the formula to be useful. So solve each formula for the given variable. So the first one has W equals FD, and it says find the force needed to move a piano given the amount of work applied, W, and distance moved, D. So at the very beginning, it says find the force. So what that means is you want to get F by itself. So I've circled it so we know that our goal is to get F on one of the sides of the equation by itself. So if I have W equals F times D, well, F times D, so the opposite of times is divide. So to get F by itself, we're going to have to divide both sides by D. So then you have your force equals your work divided by distance. Down here, this one is way bigger than the first one. So let me move my little thing. So we want to find the temperature in Celsius given the temperature degrees in Fahrenheit. Right now, this formula works really well if we know the Celsius, because then we can plug it in, find our Fahrenheit. But if you had to do a lot of these problems and I was always giving you the Fahrenheit, you'd be solving essentially the same equation over and over and over again. So what you can do is solve the formula to get what you want by itself. So in this case, to get C by itself. And then once you get it done, then you can always just plug in your Fahrenheit and boom, boom, boom. It'll always toss out your Celsius and you're not having to solve equations. You're just simplifying. So here's what this looks like. So if we have F equals 9C over 5 plus 32. Again, you are going to follow the rules of the equation. So if you wanted to get C by itself, first thing you're going to do is subtract 32. Now here's where it gets tricky, because normally this would be a number over here and you could take whatever minus 32, but you don't know what F is, so you just leave it alone. So F minus 32. So then you're left with 9C over 5 on this side. Well, the opposite of dividing by 5 is to multiply by 5. So now that you have your F minus 32, you're going to multiply it by 5, because that's what you had to do to this side to get rid of the 5. Well, now that you've got that, now you have 9 times C. So the opposite of times is divide. So now you're going to divide it by 9. And so then you would have your F minus 32, which you have to keep because you don't know what F is. Well, then you had to take that and you had to multiply it by 5. And then you had to divide it by 9. And so your equation to solve for Celsius would be 5 times F minus 32 over 9. You could have also done the distributive property here and get 5 times F minus 5 times 32, and that would be acceptable as well. So that is how you do that problem. Okay, continuing on, solving some of these equations. I'm going to see if I can zoom in without it messing too much up. So on the first one, it says that is, I don't know what that letter is. I know it's not, I don't know, because pi, we know what pi looks like. So that symbol is a letter of the Greek alphabet. Sometimes scientists use Greek letters for variables. Find the mass m of the precious stone given its density, cool looking P thing, and volume V. I am so sorry that I don't know what that letter is. Someone look it up and then send me an It's Learning message. So you want to get m by itself. So if you have P equals m over v, I just have to keep moving this thing, P equals m over v, and you want to get m by itself, It says m divide by v. So the opposite of divide is to multiply. So you're going to multiply both sides by v, and you would get your cool looking p thing times v equals m. Down here, this one is a lot harder again. You're trying to find r, the distance of the light bulb, given the I, the intensity of the light, and W, the wattage of the light bulb. So they're telling you that I equals W over 126 R squared. We want to find R, so we're going to try to get this R by itself. Now this one is a little trickier. What I would do first is think of this like a proportion where you'd have I over 1, because since it's not a fraction, you can always make things look like a fraction by putting it over 1. So you can put it over 1, and then you can cross multiply. I know some of you are scared of cross multiply. Don't be. Take I times 126 R squared, so you'll see that's what I did there. W times 1 is W. Now you're trying to get R by itself. So what you can do is you can divide. This says I times 126 times R squared. So the opposite of times is to divide. So you're dividing by the I and the 126. So now you have W over 126I. And then now all of that equaled R squared. Well, how do you get rid of R squared? The opposite of squaring a number is to take the square root. So you would square root both sides, and you would get R equals the square root of W over 126I. And again, if you can't read that on my video, the sub will have the answer key at the desk. So then moving on, I'm doing all of these examples because I feel like students really struggle with this, so maybe the more you practice and the more you hear me, it will help. So I would, again, like for you to pause the video and try 90 by yourselves. Maybe you want to divide it up and you're in the class try all 4 of these. Different people try them. Whatever's going to work, you let the sub know and tell her when it's time to pause or hit play, or him, whoever my sub is. So solve for y. So this first one, do the distributive property. You get 2y minus 6 equals 4. Add 6 to both sides, and then you can divide both sides by 2. We've been solving those for a while, so I changed my mind. I don't want you to divide and conquer because this one, and really this one down here, A and D, we've been solving those for a while. But so I do want everyone to at least try B and C. So B says solve for x. So we get 2x minus 6y minus 12. If we want to get x by itself, here's the x. We want to leave it alone, leave it here, move everything else. So the first thing we're going to do is add 6y. So then when we do that, we would have 12 plus 6y. Remember, we cannot put those two things together because we don't know what y is. So it feels really funny because we're used to being able to like put stuff together, but we can't. And then it says 2 times x, so the opposite of times is to divide. Now this is also tricky because you have to divide everything on that side. So 12 divided by 2 is 6, and then 6y divided by 2 is 3. So this is where it gets a little trickier because normally there's only one thing left to divide, and so it makes sense. It's natural to divide everything by the number because there's only one number up there. But now that there's 2, you have to divide everything by it. Down here, we want to solve for y. So we're going to add, I put my y's over on this side here. So since I had y's on both sides, so since I was to add y, I subtracted y from both sides. Those crossed out, 2y minus y is y. And then I have my y plus 8, so then I was able to subtract 8. These two things cannot be put together. I know it looks weird, it feels funny to just rewrite it horizontally, but that's what you got to do. And then here, you can use the distributive property, 3 times 2x, 3 times 4 equals 2 plus 6x plus 10. And then when you go to simplify that, you have your 2 plus your 10 here. So you're going to notice that you have the exact same thing on both sides of the equation. And since it's the same, it is infinite solutions. So pause if you need to get caught up, and we will move to the next one. Is it this one? I don't know. I've kind of lost track. Yeah. So then now, oh no, I cut off this edge. Solve for x. So we have y equals negative 2x plus 5. And so we want to get the x by itself. So first we have to get rid of the 5. So we subtract 5 from both sides. Then we have a negative 2 times x. So the opposite of times is divide. So then you divide by negative 2. Now, when you get this, you have y divided by negative 2. This would be one way to make it look. The other way would make it say negative 1/2 y plus 5 over 2, because you have a negative and a negative. So those will become a positive, and you have your 5 over 2. Up here for B, solving for P, first you're going to do the distributive property. So you have the negative 3P, and then a negative times a negative makes this one a positive. And then, well, I was hoping that was going to go away again. Apparently it's not. So then you want to get your P by itself. So go ahead and put your M's together. So this is minus 3M minus 3M. If you have M minus 3M, you get negative 2M equals 7 minus 3P. You can subtract both sides by 7. And again, you can't put those together, so you just write them horizontally. Negative 3 times P, the opposite of times is divide. You have to divide both things by P, or I'm sorry, by negative 3. So negative times a negative. Negative divided by a negative is a positive, so 2/3 M. And then negative divided by a negative will make it a positive. You have your 7/3, and then you're left with P. Down here, I decided to go ahead and use the generic rectangle for this multiplication over here. So I had x squared plus 4y, and then using the generic rectangle, or you could do the distributive property. You can tell I was about to do the distributive property, and then I changed my mind. Set it up so you have your x plus 6, x minus 2. When you do that, x times x is x squared, x times 6 is 6x. Negative 2 times x is negative 2, and then 6 times negative 2 is negative 12. These two are going to go together, so you get x squared plus 4x minus 12. When you start solving this, your x squareds are going to cancel on both sides, and you are solving for y. So since you have 4y equals 4x minus 12, divide both sides by 4. 4x divided by 4 gives you 1, so you could just have the x. Negative 12 divided by 4 is negative 3. Again, I apologize that this cut off over here. Again, the sub has the answer key, so give it a shot and see how you did. And then here, with more of closed sets, when you look at integers, you can read all of this. Basically, it's just asking if integers are a closed set under multiplication. So just to recap, integers are negative 3, negative 2, negative 1, 0, 1, 2, 3 in both directions. So I just tried some examples here. A negative integer times a positive integer gives me a negative integer. Negative times a negative gives me a positive integer, and a positive times positive gives me a positive integer. So yeah, like the integers are closed when it comes to multiplication. Every two integers multiplied together will always give you an integer. I know that because I tried a lot of different kinds and it worked. So then moving on to finally the last page of the notes. We want to do the same thing with polynomials. Now, polynomials are a little more, my goodness, it's driving me crazy. I can't imagine what it's doing to you. I'm just going to leave it small. You can look hard. So polynomials are all of these things. So a polynomial means it's going to have more than one term. Like a binomial is when we're multiplying two things by two things, where we use the generic rectangle. Same deal. Polynomial is just a generic version of that. So when you do this, I did it with distributive property, you're going to notice every time you multiply one of these, go ahead, practice, multiply, pause, check your answers when you're done. When you do that, you're going to see that they are all polynomials. So yes, polynomials are closed under multiplication. Take a polynomial times polynomial, you're going to get a polynomial. So I hope that I haven't bored you too much. I know that was a lot to go over. So there's no homework tonight. That probably took most of the class. Hopefully you don't need to finish it tomorrow. Thanks for listening.